Alright, in this new online week, I'm going to go through procedures or steps you can take to forecast uh, the price of your major commodity and to calculate the average price of your major commodity. Um, so I have posted the lecture to Blackboard. Um, So the most important goal as an outcome of this online lecture is to help you understand how to read regression summary output and how to evaluate the result of your regression and how to forecast price for your commodity. Okay, I have in this first step, I have provided you some econometric specifications of your models that you have used. This information is posted on Blackboard, and I have also gone through this information during the lecture. In the previous online sessions and in class, I have gone through two important equations with you. The first one is a price-dependent demand equation, and we used a price-dependent demand keeper regression to estimate this equation. So basically, on the left-hand side of this equation, we have your real price of your major commodity, and on the right-hand side, we include the per capita consumption of your major commodity, which is a Q, per capita consumption of your close substitutable commodity number 1, close substitutable number 2, number 3, and the real per capita income. So those variables, we call them explanatory variables. We also call them independent variables. And the P is our dependent variable, which is on our left-hand side. It is also in your head, it is just the y variable. So that's our price-dependent demand equation. And in the following here, I provide you some explanations for the variables. We have also estimated the quantity dependent demand equation. So in this quantity dependent demand equation, we have the left-hand side, which is our dependent variable, is our per capita consumption of your major commodity. So on the right-hand side, we include 5 variables. The first one is your real price of the major commodity. That's your real price of your first close substitute commodity, the real price of your second substitutable commodity, real price of your third substitutable commodity, and the per capita real income. So you have learned how to run this regression using Excel. I've also provided you several videos to show you the steps to run the equation. Here I want you to understand the directions of the signs for each of the estimated coefficient. So this coefficient would include your intercept and your coefficient for your per capita consumption of your major commodity for the price-dependent equation. Your coefficient for the per capita consumption of your substitutable product, and your coefficient for the per capita consumption of your second substitutable, the coefficient of your per capita consumption of your third coefficient, of your third substitutable product, and the coefficient of your per capita income plus an error term. So if you look at the expected sign of this coefficient, we would expect beta 1 to be negative. This is because we want the quantity of your major commodity, per capita consumption of your major commodity, which is your Q, has a negative impact on the real price of your major commodity. I mean, I want the P and Q are in opposite directions. This is because I want the demand curve to be downward sloping. So this beta 1 need to be negative. Beta 2 is the coefficient for my first substitutable product. I want this coefficient to have a positive sign, same as the coefficient for your other commodity. We want them to have a positive sign so that we can call them substitutable product. If you guys remember in lecture 1, I mentioned if the estimated coefficient is negative for your substitutable product, those products are not going to be called substitutable. Those products are complementary product. So because you have picked those products as your substitutable, those signs need to be positive in order for them to be substitutable product. We want the sign of beta 5 to be positive because here beta 5 y is our per capita real income, because income we would expect it has a positive impact on the real price of your major commodity in the case if the commodity that you picked is a normal product. If you got a negative beta 5, that means your product that you picked, I mean your major product, is an inferior good. In our regression, we also included another variable, which is your log year variable. That explains how the change of time would affect consumers' acceptability of your major commodity. For example, will the change of lifestyle affect consumers' acceptability of your major product? Will the consumption preference change, like consumers' preference for organic product, change the acceptability of your major product? So those are reflected in the log year variable. We have also included a dummy variable in our previous regression. Again, the signs of these two variables, the log year and the dummy variable, might be positive or negative. So it's okay if the estimation is negative for these variables. I also provide you a little bit background information for the OLS technique. It's called ordinary least square technique that Excel has used to calculate your coefficient. So those are the equations Excel uses to calculate your coefficient. So because of the rules here I listed on this page, this is the rules. We want the estimate coefficient to meet our expectations about the signs of your variable. I need you to carefully check your output summary to find out if the signs are within your expectation. So I basically want you to check if the first sign is negative or not. I mean the coefficient for your beta 1 is negative or not. If the coefficient for beta 2, 3, and 4, if they are positive or not, and the coefficient for beta 5 if it is positive or negative. So I want you to, number 1, check the sign of your coefficient. Number 2, I want you to check the p-value of each of your coefficient. Like I mentioned, if the p-value of the coefficient is less than 10%, that means that estimated coefficient is going to be significant, and we are going to keep that coefficient in our finalized regression. I've also mentioned many times in the lecture that I want you to check the f value and want to make sure it is at least 5. So you want it to be greater than 5 or equal to 5. And I also mentioned the R-square value need to be 80% or above. These two values help us understand the goodness of fit of your model. That means if the model is valid. In the case if the model is not valid, we are not going to continue to explain the coefficient of each of the variable. So in this short video, I tried to help you understand the importance of checking the signs of your coefficient to make sure the signs of the coefficient makes economic sense. Thank you.